going to enjoy every bit of it, just like the other speakers. So let's get started with Ed. Thank you, Ed.
All right, great. All right, good. Yeah, as Ruth says, I'm Ed Hightower with Blackberry, but I'm not speaking on behalf of Blackberry. I want to make that clear.
Oh, sorry about that.
Yeah, no problem. But I enjoy the Internet of Things. Is something I discovered a couple of years ago. I was searching around for, I love to keep up with technology, and I discovered this protocol called Weightless, and it is a low-powered wireless technology that's going to enable a lot of Internet of Things connections. And when I started searching into it, it was cutting edge. It was this new thing coming out. And I got asked, a good friend of mine is the director of the IEEE, the Communication Vehicular Technology Group, and she asked me to come and speak to them about this new topic. Well, I asked her, says, how many months out do I have to prepare for the presentation? She said 8 days. So I had to go in and really dig in to understand the topic. And that got me started on the route to understanding what Internet of Things is. And it is a huge, and it is going to be an incredibly powerful change or evolution in what we're doing now. And giving us data that we haven't ever had, or insight into things, and hopefully you guys will pull the data, pull that information out of the data to give us insights into things that will help us make our life much easier and more efficient. So I'm going to give you kind of a quick background on the history of how machine-to-machine has evolved into the Internet of Things, and explain what machine-to-machine and all this is. And then the Internet of Things is very complex when you start digging into the details, but I've broken it down into 3 areas. We're talking about the remote devices, embedded software in the devices and whatnot, the networks that will connect these devices back to a back end, and then the IoT platforms, which will include the data analysis and the cloud and all the infrastructure that will allow this data to be manipulated and analyzed. And then, very interesting, some things I read about on the platform economics and network effects. So we'll get into that a little bit at the end there. And if we have time, then we'll do some, I just mentioned about standards and security and privacy. And then we'll do Q&A. But if you've got some questions along the way that are very pertinent, we can do that. I just don't want to run over and take a lot of time of you guys, but we can make this interactive if you'd like. So, I'm not speaking on behalf of Blackberry. I need to make that very clear. I just have followed this for quite a while now, and I want to thank all these people that have published information, these companies. There's great information out there. Google is my friend. So machine-to-machine has actually been around since the 1800s, but I got involved many years ago, and at that time it was called telemetry, SCADA, supervisory control and data acquisition. It was also called industrial automation. And since that time, then telematics, talking to cars and whatnot, has taken off. So the technologies that enabled that in the old days, there was wireline when we first got started, and then microwave and private radio. In fact, when I sold the first Interact system, which was a machine-to-machine system from Motorola in Houston, we used private radio. We had mechanical relays and devices in the field, and it on, off, and maybe an analog input or something, and maybe commands to turn things on and off. And that was it. Pretty rudimentary. Then we had a mainframe on the back end. So that goes to show how far things have come now to what we're doing. So since the private radio, then we've come out with Wi-Fi and then satellite communications, which has its place, but I'll talk about some of the issues with that and with all these technologies. So when we first got started, it was very simplistic in what the capabilities were. They're very vertical, the early machine-to-machine implementations. They dealt with one domain, one industry, doing one certain capabilities. We weren't looking at very broad capabilities. You're just trying to take care of one set of requirements. Then over time, it's evolving, and we're beginning to expand what these systems can do so that they can reach into more and more devices and areas and remotely monitor and control is the other word for what we're doing with machine-to-machine. So it's getting more broad along the way. And that's going to take us into horizontal platforms, which I'll talk about more in the end. But we're beginning to really expand what we can do. Now, it's interesting to look at the marketplace. It's a very robust marketplace, but it's very segmented. There's lots of people out there doing things with machine-to-machine and now the Internet of Things. What's good is there's a lot of brilliant people working on this. There's a lot of innovative ideas being floated around. It's chaos. It's the Wild West, though, right now. So it's going to take a while for these users, or for these companies and these developers and people that own the technology or have ideas for the technology to finally come together and coalesce and start coming up with innovative ideas and moving them forward. And one of the things that's holding us back right now are standards. So we're going to have to see that begin to coalesce and some standards to catch fire, either be de facto standards or standard organizations to get prominence and start helping these companies then focus and come up with solutions. So this is an excellent definition of the Internet of Things. There's several of them. I had one that was 3 paragraphs long earlier, but this really succinctly describes it. Intelligent connectivity, the Internet of Things is an intelligent connectivity of physical devices. So we're instrumenting the world and digitizing it. And that is going to drive massive gains in efficiency, business growth, and quality of life. So there's going to be a lot of things we're going to be able to monitor, know, understand, and react to that we've never been able to do before. So by that, creating this Internet of Things, which will be a worldwide implementation eventually, that's going to become the nervous system for the planet. And we'll be able to then optimize and make things more efficient. So smart cities, power distribution, digital battlefields, self-optimizing supply chains, hyper-targeted markets and products for those markets, and healthcare. So there's lots of different ways that this is going to impact us. Now, Andy Groves was a co-founder for Intel. He witnessed and was part of the growth of the electronics industry over many years. And in 1999, he finally came out with a book. After all this, living through all this challenge of being in that industry, he realized that there are inflection points. Inflection points are when business models change, when there are game changers in the world that make the way we do business, the way we operate our lives, change significantly. So he identified several of them. In '58, Jack Kilby, here with TI, and Robert Noyce out on the Silicon Valley on the West Coast, both of them simultaneously came up with various ideas on the integrated circuit. And our whole electronics industry and life right now is based on what these guys did. By their creation of integrated circuits, we are now riding exponential technologies, particularly in the electronics world, and what's now become known as Moore's Law, that every 2 years the processing powers of these integrated circuits, the microprocessor chips in particular, are doubling. And when you start doubling every 2 years, it's incredible what happens then, and it becomes exponential. And that's where we're at right now. That's why the Internet of Things is possible, whereas machine to machine, back when I first got started, was very linear and very slow and very not very powerful in its capabilities. Now this is going to become incredibly powerful and insightful and useful. The other technology, or other things that happened that were inflection points, when Bell Telephone had their monopoly, they held down innovation. They wanted to hold on to their customers and the way they did things. When that was eliminated, our present communication systems have now are a result of that. And we would not have had cell phones and the kind of communications we have now if it hadn't been for that. Early 80s personal computers, internet came to the masses in the early 90s, and then Steve Jobs changed the world when he came out with the iPhone. And that's a platform in actuality, that smartphone. So we'll talk about that more in a moment, how that applies to the Internet of Things. But these kinds of inflection points have been happening along the way. But we're about to be involved in a tsunami of change. This inflection point that Internet of Things will bring will dwarf anything that's come before it. And it will change so many things in so many ways that in 10 years we'll look back and go, what happened? So it's exciting and interesting and scary time. It just depends on your position and perspective. So some companies, Ericsson, Cisco, several analysts are saying in 5 years, now less than 5 years because they're saying 2020, that there'll be 50 billion devices connected out there. Right now we have maybe 5 billion. So we're going to have 10 times more devices. Now it could be 25, it could be more. But this starts giving you an idea there is belief that this is about to take off. Now, it'll be kind of slow here for the next couple of years, but at some point it's going to really accelerate in the adoption and the implementation of Internet of Things. So that's going to drive a lot of data. It's going to collect a lot of and bombard our networks and our systems and our storage and our analytic tools with data. So I hadn't looked it up. You guys probably are familiar with this more than I am. I know about megabytes, gigabytes, terabytes, but I didn't know petabytes, exabytes, zettabytes, and yottabytes. We're going to be getting into zettabytes before long. So it's going to be incredible amounts of information. How do we handle that? How do we structure it and throw out the poor data that's going to be collected? It's going to be an enormous task. So you guys have got your challenges. So the ecosystem for the Internet of Things is very complex. There's lots of different things, and the whole system can be very involved with all these different parts. So I'm going to boil it down, though. I like to talk about the three different components of the IoT. There's embedded devices, there are networks, and there's two parts of the network that I'm going to talk about today. The last mile, which is typically a wireless network of some sort that gets you from a tower into the home or into remote areas or into a building, not necessarily by wireline. Then from the tower and then back through the whole network, you've got another infrastructure that we'll talk about a little bit. Then the third part are the IoT platforms, which will include your analytic tools, but also the storage and how that information is related. And in the past, we've had these vertical implementations of IoT. Those platforms were also vertical. Now they're going to be horizontal. And I'll talk more about what happens when you start making your platform horizontal. So, embedded devices, lots of them. When we first got started, the devices were oftentimes mechanical devices, relays. You could get on and off to know if something happened in state change, or you could send commands out and turn things on and off with that relay. You might have an analog signal giving you temperature or pressure or something like that. That's what I did for Intex Gas, which was down in Houston. They had wire lines going way out. The lines were unreliable. We got them frequencies. They put in a radio network. We were able to monitor the pressure in the lines. If they went too low, we turned them up until it got to a certain point, turned it off. So that kind of thing was very rudimentary back then. And it was a private radio network. If you didn't, there weren't any frequencies allocated for this kind of stuff other than if you had to have your own frequencies for your company or your industry and whatnot. So, and the back end was also, very rudimentary mainframes in my case, and then it became minis and then other processors along the way. Nowadays, however, the sophistication in the remote sites is pretty incredible. Again, we're writing Moore's Law, so every 2 years we're doubling the horsepower of the processors and the memory and other electronics in those devices. What makes up those devices is typically now that you can have very simple devices with a sensor and just a transmitter so that you once in a while know what that status or state is at the remote site. Or you can have more sophisticated remotes and they will have intelligence built in. So in that case, they'll have sensors and actuators so they can turn things on and off. And then you'll have the processors and memory. You'll have a transmitter and a receiver in the device. And then you'll have embedded applications. And then an embedded operating system. Now, depending on the need for reliability on that remote device, your operating system in that case could be just a standard operating system that dies from time to time, which is not a good idea. So these companies are the ones that most remote sites use if they have to have some reliability built in. So QNX is a hard real-time operating system, as is Wind River. I used to work for Linux Works, excellent. Green Hill Software, DDI. There is a hard real-time version of Linux that's out there, Mentor Graphics and whatnot. So, and the companies that implement those are just examples there. Samsung is going to be big in the Internet of Things, and these other companies are also pushing very hard. So you're going to have the ability to choose, if I was a designer, architect, or whatnot, the ability to find the right kind of reliability, operating system, memory, and intelligence that you can put into the remote site to do whatever you need to do. So that opens up a lot of things. This whole thing is a canvas. So depending on how futuristic you are, how involved you are in a project, in the requirements of a project, how you see things could get better in the future, you now have tools that are going to be able to allow you to do a lot of things that were not possible even 5 years ago. So, and the other thing that's going to happen because of this Moore's Law, yeah, go ahead.
Question. I understand, I hope everybody else does, the sensor side of the world, and I think all of us understand the cloud side of the world, and there's, for the Internet of Things, there's going to be a connection between. Some of the reading I've done point to what they call a fog in between those two for some of the consolidation and of the information coming from this huge amount of devices and data coming in, rather than driving it all the way into a cloud solution. They talked about, if you will, staging it at a house or at some consolidation level. Have you seen discussions?
Yeah, in fact, that's part of what I was going to talk about in a minute, because with this intelligence, you may have the opportunity to create the ability to structure the data somewhat and throw out the poor data that's involved in what's being captured. So that's what could possibly be the fog that he's talking about. It's an intermediate step, and that might be a way. We're going to be overwhelmed. It's going to be a tidal wave of information. How are you going to deal with this once it comes in, if you've got to deal with all of it at that point? Now, you'll have horsepower and parallel processing to work with on the back end, but if you could eliminate a lot of that on the front end, that might help, and it might be part of the requirement, because you'll still get a lot of information back you have to deal with. So that's a good point. There may be a way to do that. If you're being innovative and thinking ahead, you might start designing the idea of how can I manipulate the data beforehand to do a lot with it before it even gets, let's manage it, massage it somehow before it gets sent back. The devices are going to become ubiquitous. We're going to have devices everywhere, and we don't even realize it. And we already have them in our phones and in places that we don't even recognize as we're going along. They're tracking us now and tracking different equipment and different things. It's just going to get more pervasive. They're going to be smarter, smaller, more economical, so they're going to be able to be put in more low cost. The problem with the past, with machine to machine, the whole system was very costly. You had to build it one at a time. You had to develop for that particular application. The equipment was very costly at the time, and the radio frequencies were not cheap, whatever you used. Now, we're going to see those costs be driven down significantly, so much so that things that were not economically possible or feasible to manage, monitor, and control are going to be possible now. So we can start thinking about objects that are not very costly, but their movement or their status may be important to us enough that we could afford to start managing them now.
Yeah, I wanted to reinforce that one point. One of the things I've played or thought about a lot of IoT stuff, the Raspberry Pis and stuff at the back, at the really front end stuff. But one of the interesting things I found was actually a plug-in module for a Raspberry Pi that connected to the SMS network. So you could actually send text messages. You had a pricing structure and everything for little small text messages that you could go through and send through the standard network. I mean, we're talking like $20 for this thing. And they had $1 per month, some dollars per month for the message, for the phone subscription kind of thing. So it's just that kind of thing is what's going to drive this, right?
Well, exactly. And that's just one example of a very using relatively old technology to allow very low-cost opportunities to be possible. What we're going to see here in a moment is a new technology for radio wireless transmissions, but will lower the cost even more than what SMS, which has not very much capacity, but it can do those sorts of things. This newer technology is going to be able to allow millions of devices on one cell site that has maybe 3 to 10 mile radius control of these million devices, but under certain circumstances. And I'll talk about that here in just a second. So in the past, we had wireline, we had microwave, we had private radio, and then cellular came along, and 2G, with first was analog, and then the 2G digital networks actually were pretty good networks for implementing machine-to-machine type applications. Fairly expensive. You had to have a good use case for that proved out the cost, but they had pretty good coverage. They got better over the years, and it wasn't too costly to to be able to do that. Then the cellular industry is focused on broadband, and now how can they handle all your data? And so they saw that. So they moved to 3G, and now they've moved to 4G and LTE. So their thinking and their plans are about broadband with and being able to do real-time communications. When you're talking to somebody, you need to be able to talk immediately. The data needs to be able to get through very quickly. So that's their focus. They just kind of left IoT and machine-to-machine behind. And now they're beginning to go, uh-oh. And they're already turning down their 2G networks. Every time they have a problem with the power side, they pretty much just shut it down and leave the 3G and LTE up. So, and their plans are to shut it down. Most of them shut it down completely. So that's going to become less an alternative here in the future for machine or Internet of Things applications. And of course, then Wi-Fi, when it first came out, 2.4 and 5.8 gigahertz is trash frequencies to radio guys. and yet, the innovation and the creativity of the engineers and the people looking at what they had to work with have created an awesome technology for allowing us to be able to communicate short range. You have a pretty good bandwidth, particularly at 5.8 now, and the ability to go places and communicate high bandwidth requirements without using your LTE and all your data plan. So that has morphed into mesh, which is a matter of connecting a lot of different cell sites or Wi-Fi type sites together. And then Zigbee is just a version of Wi-Fi that the utilities like. It's got a lot of security built into it. And then, of course, satellite. Problem with satellite, its frequencies are above a gigahertz. Gigahertz is kind of a magic mark in the radio land. I'm a radio guy. Below a gigahertz, the propagation characteristics of radio are that they go a long way at relatively low power and they can penetrate into buildings real well. When you start getting above a gigahertz, they act more like light. So satellite, most of their frequencies are well above 1 gigahertz, and so you got to have line of sight to the satellite. And if it's a rainy day, they won't talk even then. Yes.
Have you heard about like Google's future plans to send like 180 satellites into space?
Oh yeah. Yeah, I don't know what frequencies they're operating on, but that's low orbit, for what little I've read. And so the good thing about that is you don't have latency. And when you're only a couple hundred miles up instead of 24,000 miles up, the physics work for real-time communications and voice type of communications. They're probably going to be focused more on the data, but that's fine. And so as long as you've got good connection to the satellite, yeah, you'll be able to do that.
So is that a satellite or is it a balloon?
There's several different techniques.
Yeah.
That's what I was saying. Balloon, I thought, but
There's several different companies doing different things. Satellite is one of a bunch of microsatellites that Elon Musk is promoting to send up with SpaceX. And then there's the balloons, which is a fascinating idea. And then solar-powered drones that will hover for days and months at a time at the right level. There's hardly any wind at certain levels. So there's different ways that may come in. Let me talk about that in a second here. There are some issues that have to be overcome. It's not that it can't be, but a lot of creative thinking has to go into this sort of thing. So cellular, as I said, is a technology that was useful, especially when it was 2G, fairly expensive. The focus of the companies now are broadband for the data communications that you and I use with our cell phones and laptops, that kind of thing. So they're not watching IoT, but now they're beginning to wake up and go, we got to figure out something. I'll talk about that in a second. The other issue that cellular has is their protocols are so heavy with overhead that when you have a lightweight device, a simple device that you're trying to communicate with, and you've got to put in a transceiver that has all this overhead protocol, it just eats up the battery. And a lot of these applications that we're going to look at in the future need to last 10 years on a battery. You can't go to some of these places easily, and you don't want to do that every year or two. So cellular is not a good solution for those kind of situations, particularly now with them going to higher power requirements and more overhead. And cellular is not a good thing for what we're going to try to do for the majority of devices. Wi-Fi, Zigbee, Bluetooth, mesh, Bluetooth LTE, that kind of, or low energy, are possible it's your backhaul costs that need to be worked out. That could get very expensive. But Google's looking at doing that as well. So there may be ways that if you have your network and you have enough coverage with your backbone for backhaul, you might be able to support a Wi-Fi type of network or a mesh network, whatever, in the future. But that's going to be a challenge. Then, of course, you got private radio and microwave. They're out there, but they're not ubiquitous, and they don't have a lot of bandwidth. But they could be used in certain situations for certain industries. If you have frequencies across the whole nation or frequencies around the world, it would be ideal. And then, of course, satellite, which I said, is typically very expensive and doesn't really get into buildings and deep penetration. So that has some limitations. Possible, but not necessarily good. So machinery, I love these guys. Machinery Research puts out a lot of good information. So if you want more knowledge about this, do research through some of their papers and whatnot. I'm surprised at what they put on the internet. Very, very useful information. They've done analysis, and they see that the coming implementations of IoT in the marketplace, over 50% of the devices that we want to connect to don't need a lot of bandwidth. They just need a little bit of a few bytes of information on a periodic basis. Maybe an hour a day, maybe once an hour or once a day, or even maybe once a week, whatever. It's not very often. So there's not a lot of bandwidth and not very often that needs to talk in. And a lot of these devices, we just need to know they're still there, they're still operating, maybe get a reading from them once in a while, and that is not time critical. It doesn't need to be real time. So a few seconds delay is okay for a lot of those applications. One key thing is the long battery life. It needs to last at least 5 years. 10 years is the design focus that a lot of these companies that I'm going to talk about in a moment have. Working off a AA battery, maybe 2 AA batteries, for 10 years so you don't have to go out and mess with it. And then you need to be able to penetrate into buildings. So anything above a gigahertz for wireless frequencies is not a good choice unless you're in the building, maybe. But you need to be able to get into it somehow. So when Machina looked at all this and reported this out, it leads to the fact that, okay, so we have a technology that will allow us to be able to reach into buildings, to be able to talk long distances at relatively low transmission powers and therefore low usage of the battery consumption, and be able to send a few bytes of information as we need it, either as state changes or we need to send something out and change something at that end. And that's called low power wide area networks. Now, I got started 2 years ago when Weightless was being developed. Weightless is a protocol that was developed in Cambridge, England, by a group of industry experts and companies that wanted to try to find a way to enable the Internet of Things. They saw it coming, and they realized that what technologies we have now and the frequencies and the way we're doing it now is not going to support the 50 billion devices coming up. So below a gigahertz, you have your TV white space frequencies. And TV white space, here in Dallas we have somebody transmitting on channel 21, somebody channel 23, but nobody's transmitting on 22. That's white space, TV white space. The FCC 2 years ago, maybe longer, passed rules that allow companies to go in and use these TV white space frequencies for free, but they have to be low power and not interfere with yours and my big screen TV. But they can transmit on 22, just put up a tower and go for it if you meet the rules. Well, these guys in England, they actually came together because their leader was with their FCC, it's called Ofcom in the UK. For 7 years he did analysis on the TV white space and what it would take to coexist with the TV transmitters over there and your receivers, your TV big screens. And he came up with some ideas and protocols and things that he proved out at the Ofcom and then brought these guys together to create an open standard that would utilize this TV white space spectrum. They announced the protocol in April of 2013. It looked like it was going to take off, but the problem is the United States had passed the rules to allow it. The UK still had not at that time, and just passed the laws to allow TV white space transmissions earlier this year. those are only two countries in the world that have passed rules to allow use of the TV white space legally. And so we have to wait for the legislature to catch up to the technology. So they backed up and they went, uh-oh, okay, what do we do now? In the meantime, a company called Sigfox out of France realized that there's another set of free frequencies below a gigahertz, and it's called ISM band, Industrial Scientific Medical Band. Here in the States, it's 902 to 928, just below a gig, so it works really well. In the rest of the world, it's typically 868, give or take some, frequency. Sigfox created an ultra-narrowband technology on those ISM frequencies that they installed in France, and now they've installed in about 10 other countries, and they're putting it in Silicon Valley now, and will eventually cover much of the United States with this low power, long range, 3 to 10 miles range. 3 miles if you're trying to get into buildings because of the penetration capabilities, 10 miles if you're kind of in a semi rural or semi-urban area. And they've taken off. And they've gotten $115 million in VC money to support them as they grow into all these other countries. They have a proprietary standard as opposed to the weightless open standard that anybody can access and use. Their business model is to partner with companies in a country, and these companies are typically already embedded in the radio infrastructure there. So typically they're running the tower sites, or they somehow are connected with the infrastructure that's in that country. So they understand the rules, the regulations, they have access to these towers that are needed. And so Sigfox does a sharing agreement and let those companies then run their networks in those particular countries. So they are just taking off like bandits, crazy. So Weightless came back and said, we need to modify this Weightless W standard for white space and come out with narrowband protocol that was supposed to work in the ISM band. And so they just announced that March, actually 1st of April of this year. And so it's not exactly the same protocol, but it's very close to what Sigfox, very similar to what Sigfox is doing, will work in the ISM bands and could be adapted to work in other frequencies as well, white space or subcarriers or whatnot of the cellular. So the thing that happened also, cellular is moving toward the broad bandwidth, but there's a group of people inside of these cellular companies going, we are going to miss the boat if we don't back up and figure out a way to support these low power requirements. And so they're in a process right now with their standards groups. That's the problem they have, is these standard groups are all the carriers around the world all trying to put their 2 cents in. And so their protocol they're working on will probably not be decided until late next year, and it may not even be a good enough protocol to support the low power requirements that some of these implementations require. So they got issues. So it's a very interesting time. There's a lot of things happening out there, but watch for Sigfox. And the other company that's doing low power protocols is Simtech. They came out with, I don't have it on this slide, they came out with what they call LoRa WANs, long range WAN technology, which is a proprietary protocol, but they may open it up, which is using spread spectrum in the ISM frequencies and could be used in the white space frequencies or the subcarriers and whatnot of the cellular. And they're moving very hard to, they already have a good ecosystem because Simtech is a large semiconductor company out of the Silicon Valley area, and they have a lot, in just this last 6 months, they have just exploded with information and announcements of their partnerships and whatnot with people around the world. So watch for them. Those 3 protocols and approaches are the 3 to watch for low power WAN implementations. Weightless, Sigfox, and Simtech with their LoRa WANs, or LoRa Alliance is the group that got together. Yes?
How are these companies able to scale, right? So you need to, you said most of these companies could be like a protocol, they create their protocols or the chips, right? But to scale, they would still need to have the towers, the network as such, right? So where is the network infrastructure for those?
Okay, so your question is about how these companies can scale. Okay, so Weightless is not a company. They're allowing this protocol to be used by anybody that wants to implement. if they implement all of these ISM frequencies or eventually the white space frequencies, no cost, no regulations restricting them for putting up a tower site, but they do have to meet the power transmission and other characteristics on that site. So it's free. That's weightless. It's a protocol given to anybody that wants to implement. Sigfox is a company that's partnering, and so they're putting their systems with our partners in these different countries to meet the ISM regulations and give them coverage on those videos. They got $115 million. They're moving fast. So they'll be the ones that scale the quickest.
The example that you gave, right, you said in West Coast you have 3 mile and 10 mile radius, they're covering it up. So there should be some kind of a transmitter or a network, a tower outside, right? So
Yes, yeah, it's just very similar to cellular technology. They call it a star network. So you've got all these tower sites, and they are connected with backhaul then to the back
Would it be
end.
much easier for a telecom companies to hop onto this particular and say that, oh, we already have.
I've said from the very beginning, cellular companies need to jump on one of these technologies and put it in parallel to their cellular networks. But their mindset is not there yet.
Because what we see in the TV and the most the field is LTE, right? So everybody is on the LTE bandwagon in saying that, because that is also now can run voice, data, or whatnot, or even video on LTE. So everybody is doing LTE as their primary goal.
And that's the problem the cellular companies are having. Their mindset and their momentum is toward broadband, give you more capacity, and not toward the low power Internet of Things requirements. And some groups are trying to figure out how to get back there. But they have the infrastructure, you're exactly right. They have the infrastructure, the back office systems, the OSSs and the BSS systems to support that kind of network. But they're all about protocol, about standards. Their standards coming out of their 3GPP group. And that group is working hard to come up with something, but it's going to take a while and it may not be necessarily the right thing for this kind of application. And the third approach is Simtech with their LoRa, and they've got a lot of people in their ecosystem and just now beginning to really take off.
But then we have different players right here, like proprietary, something like Semtech and Sigfox. So then they have their own implementation. So then what would be the business application usage point of view when the devices are manufactured for supporting this proprietary specific things? How will they choose one with Sigfox versus Semtech?
It's a land grab. It's the Wild West right now. So Sigfox is on the wagon, and they're running fast to implement their solution. And so they're hoping to get market share and get customers that can use their application, their architecture and their networks for whatever application that they want to do. One of the things is bicycle tracking, if you have the rental bike thing. Another is track your dog, that sort of thing. And there's a lot of other applications where you just need to know where it is it still working, has it moved, what's the reading, is there some sort of change of state. Something very simple. They're going to put in their network as quick as possible to capture those immediate requirements. Whereas weightless is a protocol that's open to anybody, but it's behind the curve. It's like GSM and Wi-Fi. It's an open protocol that everybody has agreed to, that anybody can use. There's no licensing fees. They call it FRANZ and FRANZ-Z. So it's going to be easy to implement, to adopt those protocols. And then you've got intercommunications between devices because they're all using the same protocol. The problem with Sigfox is that they own the licenses and whatnot, so whoever manufactures for them, fine. But if anybody wants to manufacture that's not part of this license agreement that they work out, you're out of luck. And they have a stranglehold in it. That's a problem with proprietary protocols. You can strangle the industry. You gain money for short term. The owners of the company will do well, and it's people in the right place. But for the community and for everyone else, you're out of luck. Eventually, their proprietary technology will not be the right choice for the long term. That's my opinion. And it's proven out several times with these different protocols that we've had in the past, Wi-Fi and GSM, Bluetooth, those kind of things. LoRa, and to be fair, Sigfox is apparently talking to 3GPP, trying to get some of their ideas across, and maybe let that be in their standards. And LoRa WAN is talking about opening up their standard as well. So there's some possibility that these standards all may become open, and then anybody can manufacture to them. If that's the case, then we're going to see a lot of 5 minutes. Okay.
Good.
All right. So based on that, TV white space. I've already talked about that. On the use frequencies, ISM bands below gigahertz. Wi-Fi is too high to be really long range. Cellular bands may be good choices, particularly the subcarriers and guard bands and whatnot. That may be possible. These are the guys, the players that I just now talked about, and they're letting both be WANs. This is awesome. If this works out to be true, now there's a lot of radio guys that say he's full of bull and that it's not possible. But do a search on P-Cells, P-Waves, or Steve Perlman, P-E-R-L-M-A-N. He's been working for 10 years with his team. He actually came out of Apple. He created QuickTime and then a couple other technologies and made all this money. So the last 10 years, he's been developing this thing. It's called P-Cell technology. If it works, then it will revolutionize radio communications. I won't say anything more about it. Go look him up. Go look at the Stanford lecture that he did. He actually demonstrated what he's talking about. If this works in the real world, he will change the way communications is done. Not only for broadband communications, but IoT. He has an IoT protocol as well.
All these ultra-low frequencies, will they interfere with the regular human functioning?
They're non-ionizing.
Okay.
If they were ionizing, yes, but they're not. They're non-ionizing. Now, so it can be argued that if they're high enough frequency power, transmitting right into your brain when you're holding it up, to be possible to cause cancer. But that's still, a very controversial thing. But it's non-ionizing, so for the most part, if you're far enough, if you got any kind of distance at all, you should be okay. Okay. The other part of networks is the infrastructure. And right now, our present infrastructure is hard, but it's hard-coded, and so you can't go in and change it. You can't manipulate it as your needs are changing on the fly. That's going to change. SDN, software-defined networks, is what the academics and the planners are proposing. Software-defined networks allow, theoretically, a network operator to go in and change the way. In fact, this is what it talks about. Okay, so you've got, think of this as a computer. So this is your hardware of your computer here. So these are the network elements, your switchers and other network elements in your network out there. The next level up is your operating system. So like in a computer, this is telling the hardware what to do. And then above that, you have applications. And the applications depends on what you want to accomplish with that. So they're trying to do the same thing with networks. The problem is the networks, all that stuff is hard-coded. It's not able to be implemented. This is a very high-level view of what it should be. So what they've come out with, what the vendors are coming out with, is what they call network function visualization. And that idea is that they're taking each of these levels and trying to add in that programmable capability at that level. And eventually, they'll get to this big overview SDN capability where they can then start letting applications control this control plane, the operating system, if you will, and then do things with the hardware that lies underneath. We've got a long way to go because a lot of this stuff exists right now. It's not going to be able to be changed. So there's a lot of interaction between the big data that you guys are going to have to deal with, the analytics you got to come up with to handle all this, and the cloud that's going to be the storage and the processing power behind all of this. SDN will allow the use of the sharing, the transmission, the moving this data around, and the Internet of Things, the different mechanisms that I was talking about earlier, will collect all this information and bring it in. And you being able to analyze the data on the front end and do something with it maybe and massage it somewhat and eliminate some things might help streamline, but you've got to be dealing with the back end on how do you deal with this unstructured data, this huge amount of data, and how you're going to get useful information out of it. So you're going to have your hands full. Okay, almost done. So the thing I wanted to talk about for a second is the platforms, vertical platforms, all these domains that were siloed. Now we're going to create what we call horizontal platforms, and many of these vertical inputs are now going to be available to a horizontal platform. So that's what Steve Jobs did with his iPhone. He created a device that allowed all these inputs from the internet to come in, and then he had physical functions in the phone that developers, people that had a need or were very innovative, and they said, hey, if I could take this information and use the equipment that's on this phone, I could do different things with it. That platform then led to thousands of applications that are now available on the iPhone. Same thing's going to happen here. With our horizontal platforms, we're going to be able to take data from all these vertical domains, and then with the proper licensing and sharing and security and privacy concerns worked out, that's going to be a challenge, you as a developer are going to be able to take this information and do things with it that were never possible before. You're going to be able to monitor, manage, control, understand things about the world that were never possible before. And when you do that, when you've got a platform, the definition of a platform is that you've got a standard that everybody agrees to. It's a governance model that all the participants know who's going to get what. If I allow you to have this information, what do I get out of it? And what do you have to do to meet the requirements to get that data? When you do that, then you combine that with the idea. When Alexander Bell created the phone system, it was useful for the people that had phones. So you had a couple of people, a handful of people on the system. Not very powerful. But as more people began to add to the network, the power and the value of that network started increasing substantially. And the phone system became our way of communicating that drove our economy, and still drives our economy in so many ways. The Internet of Things is going to become the same thing. We're going to have a network effect. So as more and more pieces of equipment, remote and whatnot, get brought in and available to this horizontal platform, we're going to be able, the power and the value of the whole Internet is going to, the Internet of Things is going to become that much more powerful. Did you have a question? So I'm almost done. Network effects, okay. And standards, the great thing about standards is there's plenty to choose from. So right now we're in the Wild West until the different organizations get predominance, then we're going to have a lot of different things to choose from. Cisco probably belongs to each one of them. So they'll win somehow, some way. And then security and privacy, that's a thing that we need to think about. When anyone designs a system, they need to be thinking about end-to-end security from the very beginning. When you start getting data from that remote site, we need to figure out, make sure that no one can hack that data, because we're going to be relying on it for our cars, for our homes, for our planes. The things that we take for granted now that we have control over are soon going to be out of our hands. And if we don't have security built in, we got problems, physical problems. And then privacy, that's going to be a whole different issue. That's the other side of the coin. How is all this data going to be kept private? And that's a question for another day that will take a long time. So this is it. The industry projections are $1.2 trillion in 5 years. Some say 1.7. So after that, we start getting into trillions of dollars, because we're on a exponential curve. So the capabilities and possibilities for the Internet of Things are going to be huge, and the economic return is going to be just as big. That's it. We did our Q&A during the session. Unless you have something now, if I got any time.
Can you please go back to previous?
Go back to what?
Yeah, last time. So, what factors are behind Europe and Asia Pacific being the front runners in the revenue? Like they're almost 2 times than North America.
Number of people.
People are things.
Population.
This is one person's opinion. The UK has been a center for a lot of creation of IP, intellectual property, which they're sharing. Asia, I was just talking to Maria. She's been going to the channel on a regular basis. They are very aggressive at implementing the Internet of Things because they want more control. And you know of who, you know of what. But there are economic reasons, there are political reasons, and there are opportunities out there that people want to take advantage of the Internet of Things is going to make possible. So if you're a visionary, a futurist, or innovative person, you have the possibility of creating some things that will change. There are going to be new Googles, new Twitters, new Amazons in the near future based on the Internet of Things. So it's going to be fun to watch and see what happens. You were first.
So that was a lot of information, good information. You have researched your topic.
Thank you.
So if you would give us some 1 or 2 companies where we can put our money now.
I would put some money on Sigfox. You know, what is it the investors say? Oh, Google says 1 out of 10. So I pick out 10 and put some money in those 10.
But Sigfox is not public, right?
Not public. They have, but so sorry, you're out of luck. but Simtech, what's Simtech in the LoRa Alliance and LoRa WAN? I think those guys have got a lot of stuff going on behind the scenes that we don't know about because they just popped on the scene in the last 6 months, and I've been watching this for 2 years, and I thought they were very low in the planning stage, and they've done a lot of stuff because they're a very huge company doing integrated circuits and electronic stuff. So I think we're going to see them. Yeah.
You said Sigfox, you didn't mean Semtech.
Well, okay, I meant Simtech with LoRa WAN, LoRa Alliance.
Got it.
Okay, so Simtech. Sigfox is private, you know, they got that investment, so they're going to take off at some point, they may become public. But Simtech is somebody to watch. Now, whoever adopts some weightless protocols, which Huawei may and some other companies may, watch those guys. Because they may take off as well, because they're using an open standard that other companies will be able to have interoperability standards, you know, and agree that everybody's equipment will work on a weightless N group. And the weightless W standard will eventually be used when other countries allow the use of white space frequencies in the TV band. The TV band is below a gigahertz, and it's the same band all around the world pretty much. So it's people, us radio guys, our mouths have watered over that set of frequencies for years, for decades. And the broadcast industry wrapped it up many years ago and said nobody can use these, even though nobody's transmitting on half of them. For the longest time, UHF was never used. So that's when that gets allowed in more countries around the world, then the economics of scale kick in, and you'll see companies use the weightless standard, weightless W standard more. So,
what about the consumer and industrial consumer electronics companies like Samsung?
oh, Samsung's going to any consumer electronics company that is seeing the future is already working on how can they make their equipment interoperable with some sort of Internet of Things technology. The problem is no standards. So they may create, don't buy anything right now. So, because you may not work, you know, 5 years from now. So their standards have to be adopted.
Semtech just missed their revenues by almost 12%.
Good time to buy.
I don't.
So how do you see the convergence of this Internet of Things with these devices transmitting whatever low amount of data every few seconds with big data itself? Like, how do you see the convergence? Where do you see the application of these?
Because there's going to be so much data collected, and it's going to be unstructured, and it's going to be of poor quality. How do you guys deal with that now? I'm not a data guy, so I'm just presenting what's going to happen. You're going to be overwhelmed with huge amounts of data that may make no sense to anybody else and may be of no value to anybody. But if you are able to somehow pull the right information out of that, you might be able to create insights and solutions that are not possible now. So that's the thing about big data. I've only studied a little bit. So much of that data looks like chaos. How do you make sense out of that chaos? And that's your challenge. We're giving you the opportunity. We're going to bombard you with all this stuff. You've got to figure out how to deal with it in some way that's reasonable and effective.
Did you watch Jurassic World? Anybody? All the dinosaurs have the IoT thermal sensors, and there's a central imaging station, you know, where they watch the heat maps, where the dinosaurs are moving and where they are, that Indominus Rex I don't know if anybody's seen the latest movie. It's all built with all this IoT and big data stuff.
So go to Jurassic World and then come back and tell us.
But I have a
That's the
question.
future. Isn't
I
it?
have a question. This is all amazing, but with the threats and the security growing at an exponential rate, how do you know? So these are all, we're all becoming future cyborgs. So if somebody injects a virus, we'll lose our consciousness.
There is a, you're like my wife. There is a whole side. I like to look on the positive, okay? My hero is Peter Diamandis. If you don't know him, go look him up. Peter Diamandis talks about exponential technologies. He talked on TED back about 3 years ago on abundance. And this exponential technology is going to allow us to do things we've never been able to do. There's 8 different technologies he talks about. Robotics and computers and artificial intelligence, healthcare, and biology, synthetic biology, and robots. So, it may not be 8, but anyway, the idea is that Moore's law, you're an exponential sort of thing. So, the positive capabilities of this technology can solve problems that are plaguing us now with the wars that we fight now over oil are going to be going to water in the future, and then air and land. We're looking at almost 10 billion people here in 10 years, 15 years, whatever. So we need those kind of technologies to solve these problems. If we have the wisdom to do it, then we have the tools. My wife and you say, we have all these security risks. We have all this hacking. We have no privacy anymore. How are we going to solve that? And that's a very legitimate question. I don't know. I'm hoping that this and the wisdom that people bring to this and the power that's available to us over here will help us solve these problems over here. You have to hope. And that's, you know, I don't have solutions for that. So I hope you guys can come up with something.
I think we need to invest in cybersecurity also. That's a lot of money is there.
Invest in cybersecurity.
Yeah.
So I think that's it, Dev, if you want to wrap up.
You guys learned a lot about IoT, right? IoT, you did a good job, right? Give me a big hand.
Enjoyed it.
Pull you over on a Sunday.
Oh, I'm fine. I'm like you. I love doing this kind of stuff, and you know I'm not getting paid for it. I just enjoy doing it. So I'm glad you guys had good questions and nobody fell asleep. So it was a good thing.
Thank you very much. Thank you. Next up is Greg. Greg is doing the Splunk. Greg has supported us last year as well.